energy harvesting using footsteps. Walking is an unavoidable process that takes place in our day-to-day lives. An average person spends a minimum of 2,500 walking steps on a normal day in their life. Each of these steps dissipate one form of energy into various other forms of wasted energy. If part of this wasted energy is captured in the process, it can be used to generate electricity. And this can be done using the concept of piezoelectricity. Simply said, when a mechanical stress is applied on any piezoelectric material, a voltage is induced and electricity is generated. The project utilizes piezoelectric technology to capture the energy in human footsteps. The project design consists of three major units: the two prototypes and the load control unit. Prototype 1 uses a rod tap mechanism, while Prototype 2 uses a wheel tap vibration mechanism. Both prototypes can be easily connected to the load control circuit, which consists of the rechargeable battery storage to which the energy can be stored and used. The functioning of this unit consists of three major functions: the voltage display, LED light load, and USB phone charging. Prototype 1. Rod tap mechanism. The design contains an array of vertical rods suspended from a top wooden tile which strikes the plates on the bottom once a pressure is applied. The tap causes the plates to generate electricity. The average values of the design per step are as follows: a voltage of 8 volts, a current of 0.12 mA, and a power of 0.96 milliwatts. The vertical displacement of the tile is approximately 2 centimeters. This video shows the working of the full system of Prototype 1 with the load control circuit. Prototype 2. Wheel tap vibration mechanism. The design contains an array of wheels arranged on two parallel shafts, which will be rotated simultaneously by the wheel chain system to tap the plates into a vibratory motion that generates electricity. The average values of the design per step are as follows: a voltage of 5 volts, a current of 1 mA, and a power of 5 milliwatts. The vertical displacement of the tile is approximately 5 centimeters. This video shows the working of the full system of Prototype 2 with the load control circuit. The results obtained from continuous testing are presented here. Two constraints were exercised with both prototypes: method of step placement and weight of the person. Method of step placement was categorized as walking and running, while the weights were categorized as 45 kilograms to represent an average female and 75 kilograms to represent an average male. 4 combinations were obtained for each prototype, and the values are as follows. The graphs represent the comparison of the power outputs per step in each prototype for the 4 combinations. The comparison shows that running generated a higher power than walking with a higher pressure applied on the tile. It also shows a similar trend of increase in power with the increase in the weight force of a person. By comparing the two prototypes, Prototype 2 shows a higher power output than Prototype 1, which makes it suitable with respect to essentially generating power. On the other hand, Prototype 1 is more suitable for ease of movement environments on plane flow areas due to its smaller vertical displacement in comparison to Prototype 1. The designs are optimized to enhance the ability of generating microenergy, which makes it renewable and applicable in lighter loading applications. Thanking you, Team StepGen, for energy harvesting using footsteps.